Well, let's get started. First, I'd like to introduce Max Chernoff. He's literally a LuaTEX wizard. He wrote a very nice package on controls of widows and orphans under LuaTEX, which is absolutely beautiful. And I want to push you to go to Tugboat and pick it up and read it. It's really awesome, and never thought that would even be possible in TeX. And now he's back in here with comparison of TeX engines and formats. With the floor, Max Chernoff.
All right, so we're good to go. All right, so yeah, thank you very much for that introduction. Thanks. So I guess I'll begin. So we're good to go. So let's begin. So TeX engines and formats. So when most people talk about TeX, they kind of most of the time just assume we're talking about PDF LaTeX, and that's kind of all they think about. But there's a lot more to TeX than that. There's a ton of interesting formats and engines to choose from. There's so much out there. So let's begin by looking at some engines. So an engine is machine code that you run. So the engine is what runs directly on your computer. It's machine code. It runs. Wow, that's not very helpful. So it's not written in TeX. It's usually, original TeX was written in Pascal. The newer ones tend to be written in C, but there's tons of stuff, tons of choices. So I'm only going to mainly cover either the engines that are currently commonly used or some important historical ones. If I tried to cover every possible engine, we would be here for about 3 hours. So the original version of TeX is TeX 78, and it is completely impossible to run now. So the source code is conveniently available to it, but there aren't any good emulators for it. And believe me, I've tried pretty hard to run it, but I just haven't been able to find any decent emulators. So it was released in 1978, and you can't really do much with it. The current version of TeX is called TeX 82, which was released in 1983, of course. And there are multiple equivalent implementations of it because it was written in a highly portable dialect of Pascal. And of course, there's the famous trip test to make sure that all the implementations produce the exact same results. Then the next engine that we are interested in today, at least, is PDF TeX, which was released in 1996. And its biggest addition is that it adds native PDF output, which is huge these days because almost all the documents you find these days are in PDF. The addition is that it adds support for microtyping of the individual glyphs in a font to produce better justification. And it really does make a very big difference in getting a good paragraph break. So the next, I guess, interesting engine, well, there's many other interesting ones in between, but the next commonly used engine is XTEX, and it has really two big additions. The first is it has direct support for Unicode, which is huge. You can essentially type in any character you can think of off of any keyboard from any language, and provided you have appropriate fonts, it will probably just print correctly. Of course, left to right text is always slightly more complicated, but in general, provided you have the right fonts, XTEX will print anything you give it. And of course, speaking of fonts, its other big feature is that it can load unmodified OpenType and TrueType fonts. So PDF TeX can use OpenType and TrueType fonts, provided you generate the correct metrics files, but it's quite unpleasant. With XTEX, you just use the standard font command, but we'll see that later. LuaTEX was released only a year later, and of course the big engine feature there is much like XTEX, it has direct support for Unicode, and its other big feature is that it has an embedded Lua interpreter. And surprisingly, there's really not a whole lot else the engine adds. The big thing is that it's through this Lua interpreter that you can do pretty much anything. It opens up almost all of the internal node structure, and it opens up all the callbacks, and you can modify the code live as you typeset it, and it's really cool how much access it gives you. And of course, that's what allows us to use the same OpenType and TrueType fonts that you use in XTEX. Then the newest engine is LuaMetaTEX, and it has many new features, many removals. It's not in TeX Live quite yet, but it works exceptionally well with context. And that's actually how this presentation was made. So yeah, it works quite well. It's a very interesting engine. And it's the most interesting there is that it adds a bunch of features, but it also removes many of the older TeX primitives and the backends, and there's a lot to it. All right, so let's move on to formats. So a format is just a collection of TeX code. Of course, I mean, there's some technical details. Usually it's dumped from a certain run of TeX, and then it's ran with a certain command, but really it's just a big collection of TeX code. And of course, that means that generally speaking, formats tend to be able to run on any engine. Of course, many of the newer ones are engine specific. And of course, again, there are dozens of formats. Here I'm just going to include both the commonly used modern formats and the historically relevant formats. So plain is the original format. It's described in the TeX book. You all know it. You're all familiar with it. It was released at the same time as TeX 82, so in 1983. But of course, a very similar format to plain, or the basic.tex, was included with TeX 78. The big thing, most important thing here is that it was included as a base, not a complete set of macros. So the standard formatting of the plain format is pretty bland. It's, I believe, 10-point computer modern set with 1-inch margins, and that's about it. It gives you a section command and not much else for higher level formatting, but it's a good base. And of course, it's designed so that each author designs their own set of macros. So if you look at the TeX book source, there's the man mac it has, the manual macros, and they implement a complete format almost. So the next format we're looking at is LaTeX 2.09. It's the original version of LaTeX. Well, I mean, the original version was LaTeX 1, but this is still in the same family, and it's quite similar to modern LaTeX. Of course, the difference here being that it was released in 1985. It's also been obsolete for 30 years, so don't use anything I show you today in it. But of course, the interesting thing with LaTeX 2.09 is that with the standard LaTeX commands, you can just run PDF LaTeX on most LaTeX 2.09 files, and it compiles just like it did back in 1985. Of course, there's some exceptions, but it's remarkably impressive backwards compatibility. One big breaking change, and it has worked out fairly well, because if you look at LaTeX today and LaTeX from 1994, even though they're backwards compatible, it's radically different in how to write correct code, and it's really improved quite a bit. So of course, now we also have context, which of course has the X pronounced like an X, as far as I believe. Of course, just to, have some fun. And it's superficially similar to LaTeX 2e. Of course, the syntax is different, but it's quite similar. It's very monolithic. It's all one big package, and everything is very uniform. It's also not as popular, but it's fairly similar to LaTeX otherwise. And of course, OpTeX is the newest format, and it's an extended plain with Lua. So it's quite interesting in that it requires LuaTEX. There is no way around it. That's what it requires. But because of that, it actually provides a bunch of features on top of that, which is really helpful. Because otherwise, using LuaTEX in plain it's functional. It works quite well. I mean, I use it quite a bit, but it's sometimes frustrating because only the higher level stuff. OpTeX adds that, while not being the complete giant macro package like LaTeX and context. And just to confirm, you can still hear me, still see me, we're all good?
Yep, all good.
All right, well, that's always good to hear. All right, so let's move on to the most exciting thing I can think of, file names. So documents, your standard document that you're going to be typesetting is usually just named name.tex. It can have any extension if you want, but .tex is the traditional and most common extension. And this is common across all of the macro packages, all of the formats, all of the engines. And of course, that's not very interesting. So we're going to look at some of the extension modules. So plain text tends to call its extensions macros. They can also be called packages, modules. It's not really standardized. And of course, in a TDS compliant file system, if it's just for plain, it's stored in text/plain, followed by in the package. Or if it's more generic, works in most formats, it goes in the generic folder. Fairly unsurprising. Which is back from LaTeX. These are packages. The STY stands for package. And of course, the package contains things that you can use across many document styles. And of course, the document styles are called classes. And of course, they're stored at the extension .cls. And they set the overall style of a document. So context has its packages called modules. And their path is a little more complicated. It's in the context tree, but it's also stored in a subdirectory called third after that for third-party modules, and the T- is also for third. And of course, context has multiple different versions. The big ones are Mark 4 and Mark 40, or Mark 4 and LuaMetaTEX, or LuaMetaTEX, or LMTX, or it's complicated. But for the most part, the versions are compatible with each other. And of course, there's OpTeX, which calls its macro packages or packages. It calls the macro packages in the manual. There aren't too many of them yet, but they're stored in the OpTeX tree with the suffix .opm. And of course, not really directly TeX related, but when you use a Lua file in TeX, it's called a module in Lua. And of course, there's many places you can put it. But typically it goes in the TeX/LuaTEX tree if it can only be used from TeX, or otherwise it can go in the script folder if it's more general purpose. So let's look at some standard documents. These are essentially minimal boilerplate that you can use in a document just to get an idea of the general syntax and how it works. So in plain, typically you would begin by inputting a personal style of some sort. It is optional, but the default plain styling is very plain. So you're almost always going to input some personal macros. And if you want to load a package, you just input the file. It's nice and simple. And then to begin the document, you just start typing text. And then of course, to end the document, you use the by macro, which is fairly cutely named. Now, with a bit more structure is LaTeX 2.09. So again, this is obsolete, so don't do this, but it still works. So to load packages, well, optional arguments of the document style argument, and of course you set the document style with the document style command. And of course, this is mandatory in LaTeX. You can't just start typing like with plain, you need to choose something. And of course, also unlike plain, you need to explicitly begin the document with the aptly named begin document. Other than that, you just type the document contents, and then you end the document. And of course, you can also see a big feature of LaTeX is that, well, two features here are the optional macros in square brackets and mandatory macros in the curly braces. And of course, the other big feature is the environments that's begin with begin and end with end. So moving on to something slightly more modern, well, actually a lot more modern. So with LaTeX, once again, to set the document style, let's use the document class command, which is, they had to use that because they couldn't use document style because that was previously used. And once again, this is mandatory. And a nice thing here is that to load packages, you can actually use a separate use package command, which you can have multiple calls of, and there's the options you can put in square brackets before. But otherwise, to begin the document, same as the earlier version, same as LaTeX 2.09, ending the document, same thing. So it actually hasn't changed that much. So here's the context. And of course, it's a bit different from regular LaTeX. I'm still good. And of course, to load a style, you would often use the environment command. You could also just input macros or use a personal module. But whatever you do, it's optional. It's just to input some commands and set up the style. To load a package, you use the use module command. But there really aren't very many modules available for context. I'd say there's probably less than 20 actively developed ones. Not just because it's so small, but because almost everything is integrated into the core of the format itself. And of course, a big thing with context is that, as you can see with the square brackets, that's usually instructions to the machine. Anything in curly braces is typeset directly. So a bit different from LaTeX, where curly braces are mandatory and square brackets are optional. In context, they have a different meaning. So to start the document, you'd use start text or start document. And of course, the difference between the two is that start document will usually include a title page and whatnot. Start text is the most basic version. And of course, to end the document, you'd use the same stop command. And of course, its environments use start, stop, unlike LaTeX with its begin, end. So next up is OpTeX. And again, much like plain, you would typically input a personal style. You don't have to, but you usually would because its styling is similar to plain. You'd have to do it yourself. It is optional. One thing that's strongly recommended in OpTeX is to set a fonts explicitly. In plain, it just uses Computer Modern by default, but in OpTeX, its default fonts are only 8-bit, which means you can't. Any other font you'd want. To load packages, you use the start typing text. Much like plain, you end with by. All right, moving on to some font switching. This is where things get interesting between the engines. So back in TeX 78, it didn't have a font command, a font primitive. It instead had \:, which was very similar to the font primitive, but not quite. So instead of defining a control sequence name, you'd define a single character. So of course, to define, Computer Modern Roman 10 and bold, you'd just pick any letters you want, and then you'd use the equal sign and then assign the name, and then you've loaded the font. To switch between the fonts, you would the same thing, use the \:, and then the letter, and now you switched. And of course, that gives the expected output of regular and bold. Now, TeX 82 changed things slightly, and of course, we're probably mostly familiar with this here, but you use the font primitive to assign a font to a control sequence using its name. And of course, there are some keywords and features you can use after. So for example, you can scale up the font using at a specific size. But back when original TeX was released, the fonts were bitmapped, so scaling up a font was usually not a good idea. Usually you'd use a specific design size. And then switching between them, you just use the control sequence. And then of course you get what you'd expect. All right. So PDF TeX is not particularly interesting from a font end. It adds map files, so it includes the right font, but from a TeX end, all that TeX cares about with fonts is their metric. So it cares about the size of the characters and kerning, and that's pretty much it. It doesn't care about the shapes at all. Where PDF TeX is a bit different is that it does have to care about the shapes at some point, because it has to include the fonts into the PDF file, whereas a typical DVI TeX typically just produces DVI, which doesn't, and the DVI transit includes that. That's where the map files come in. But otherwise, PDF TeX is pretty much the same as original TeX. ZTeX is where things get interesting. So they've extended the standard font primitive so that if you can first of all use quotation marks to make sure that the spaces are fine. If you include something in square brackets, that's a file name lookup, which is, again, fairly similar to standard TeX. Of course, what's different here is you can just use OpenType and TrueType files natively. And if it's unbracketed, you can use a font name lookup, which isn't really recommended because font names can be really wildly inconsistent, but it works fairly well for the most part. And of course, after the colon, you can add some features. And of course, you can switch between the fonts. And here you can see I've added the caps to small caps feature, which made the capitals into small caps. And I'm running low on time, aren't I? All right. So I'm actually all right. All right. So LuaTEX, another big surprise here is that LuaTEX has absolutely no changes from PDF-TEX on an engine level for fonts. And that's really surprising because it seems like it does. But with Lua, you can make a bunch of changes. So if you use the aptly named LuaOTF load package, then you can use the standard XTEX syntax to load fonts. And of course, there's also the extension, as you can see, we can use file : or name : Otherwise, it works mostly like XTEX on the front end. On the back end, it's very different. And of course, this produces the expected results. Now, let's move on to how the formats switch fonts. So in plain, each font switch overrides your previous choices. So you set the regular, and then you set bold, and then if you set italic, it completely erases the bold. Now you just have italic. Another thing is with individual sizes, you need to set each size and style independent at the same time. So you can't just use 5 and then RM. You need 5 RM, 5 BF. And of course, that produces the expected output. And of course, all of these examples are going to produce this output. So you can just look at this from now on. And then LaTeX 2.09 is actually very similar to plain. The one difference is that its size commands are independent. So the V point, so 5 in Roman numerals, once you've set that, then you can just set bold and it remembers the size, which is quite nice. Now, the modern version of LaTeX they typically recommend that you set fonts through macros with arguments. So to set bold text, it's text BF, text bold. And again, same thing, the font sizes, though, are still switches. They're still global switches. And of course, this produces the output we're all familiar with. For the most part, context is very, very similar to LaTeX 2.09. Has almost the same command names, same idea. You can save the size, switch the fonts. It's very similar. And of course, OpTeX is also very similar to LaTeX 2.0. You set the bold, you set the italic, which gets rid of the bold. And then, of course, you can set the size with any size you want, and then it remembers the size when you set the font style. And how am I on time?
You're okay. Just go ahead, and because we can probably bump a little bit the next talk. And
all right, good. I've just got this one section left, which is more fonts. Okay. So that's just the basic font switching, and of course, let's look at some more. So let's look at what we're going to get first. So this is the output we're going to get in all of these examples. So in LaTeX, to change the font family, there is, of course, a format way to do it. But for the most part, people just use packages for that because it's fairly challenging for the most part to correctly set up a font family. But most fonts have a decent package, so you just load the package and that's how it is. Then to change the size, you use the font size command, but it's not exactly what you'd immediately get. So the first argument is the font size, the next one is a baseline skip, and then after that you have to select the font. So it's a little unintuitive at first, but it works really well with the rest of the commands. One other nice thing is that you can just nest the commands. If you want something bold or italic, you just nest bold then italic, or italic then bold. And then to get small caps, you just use text SC for small caps. Now for LaTeX and LuaLaTeX, the big advantage here is that if you use the font spec package, you can just change families by loading pretty much any font on your system. You just tell it which font you want, and then it switches, which is a huge improvement over the original LaTeX, since you can select any font on your system very simply. So with context, changing families is switch to body font and then the font name. Now, for this, you can only do the easy way for the built-in fonts, which is quite a few. Other fonts, it's more involved to set them up to load, but even that's fairly simple. Not quite as simple as the font spec way in modern LaTeX, but it's doable. And then to change sizes, you just switch to body font with the size. And of course, context also has these nice bold and italic commands, that work very similar to the LaTeX commands. It also has the older plain style commands, and small caps is, once again, the aptly named small caps. An interesting thing about these context commands is that they can both take an argument or be used as a switch. So if it knows there's a brace after, takes the macro as an argument, does it in there. If there's no brace after, it uses as a global switch, which I find kind of neat. It does whatever you want, pretty much. And of course, lastly, we have OpTeX, which has the font family command to change families, and it, again, works as you expect. And then to change the size, it's very similar to the LaTeX command in that you have to set both the font size and the baseline skip, which the baseline skip is the second one after the slasher. If you leave it blank, it just guesses and picks for you. Nice thing with OpTeX compared to plain is that bold and italic nest as you'd expect. So you can just do bold, and if you do EM for emphasis, which is italic, gives you bold italic. An interesting thing here is that its small caps command is a font modifier. So you use the caps command before the RM Roman command to modify the Roman to produce small caps. And then you get the expected output. And we have conveniently reached the end. So if anyone has any questions, well, I can attempt to answer them.
This is really useful. You should start making a comparison table so that one can really look it into detail. But I have a question about LuaMetaTEX.
Sure.
What is the idea behind it? Is to unload some old garbage collecting stuff, or?
So, yeah. So it's the big thing is, I guess, it adds some nice features. One of the some nice features are so it adds some programming things like there's after grouped instead of after group, because the regular after group command is pretty uncomfortable to use. Another big thing in there is engine level support for optional arguments. So much like the longer the outer prefix is, if you add a tolerant prefix, if it doesn't find like a bracketed or an optional argument, it just ignores it, which is nice. But yeah, another big thing is that it strips some of the older, less useful stuff, like the magnification support in plain TeX was not really used, or the PDF backend from PDF TeX is completely gone. It's now in Lua, so it can be adjusted. Or the big recent thing is the math has completely changed to a whole new algorithm, which is quite neat. I haven't had a chance to play around with it yet, but yeah, it's just an evolution of TeX, I guess. Yeah.
All right. Oh. Well, nice talk. Sorry for the problems. I don't know exactly who is the responsible party here, but it mostly likely is not work.
Oh, I do have a question. All right, let's try that. Sure, answer live. All right. So why do you pronounce context as context and not tech as tech? And ZTEX pronounced like ZTEX. Well, ZTEX is pronounced like that because that's what the article about it says to pronounce it. So I just go with that. You'll have to ask the creator about that, which is, I believe, Jonathan Q. He's not Q, I'm sure. But yeah, you'd have to ask about that, probably because that's often how you pronounce X at the start of a word. Context is pronounced like that because it looks like an English word, and that's what I've seen most people suggest to pronounce it as. It's also sufficiently, it's not popular enough that you're going to be talking about people with it in real life all the time, so I could very well be pronouncing it wrong. It's, you know, fine people. And then tech is pronounced as it is because TeX creator Don Knuth, it's from the Greek, and then LaTeX follows from that, so it's complicated.
Yeah, I think ZTEX is spelt the way it is because it's intended to be reflection symmetric.
Mm-hmm. Yeah, because ZTEX has really good bi-directional support, which is one of the nice things with it. So I think that's
why exactly
is mirrored. So,
Max, very interesting talk. What I was hoping to see in your presentation was actually something about Lollipop. So that's a format that initially Victor H put developed, and he actually typeset his thesis with it, and I've been maintaining it. So if you had any time, I was wondering if you could have a look at that as well.
Yeah, and I've looked at that before. The big thing here was time. It's actually quite a neat little format. It actually provides quite a bit. It's just the big thing is time. It's not super well used, and yeah, I only have so much time, and even if I did have unlimited time, no one would want to sit through a presentation that long. But yeah, time was the big thing there. I'll certainly look into that, though. Thank you.
Max, I just want to tell you that editing your video for making it available on YouTube later is going to be a little bit of a challenge, and you could help us if you send us the slides so that we could use the slides to make sure that we haven't missed anything on the
Oh,
video.
yeah, absolutely. I'll send those to you right away. Yeah. Oh, and I do have a question. Do you know what the aim of OpTech is? What is the idea behind it? So the idea behind it is essentially that LaTeX and context are too complicated, which is really quite fair, and that they do, I guess, not that they do too much, it's that they obscure what's happening. And the problem with plain is that it provides very little. Like if you want a hyperlink in plain, you have to implement that yourself, including graphics, implement yourself. If you want to, you have to implement everything yourself. And the nice thing with OpTech is that it's modern plain essentially. So it provides the minimal framework that you can get by with. And it's quite nice too, because similar to the LuaMetaTEX, gets rid of all the old craft because it's modern. It's from 2019, only supports LuaTEX, and it's actually really nice to use. The disadvantage to it is that you have to know your tech fairly well because it's a plain format. You have to build everything yourself. But the idea behind it is essentially a modern plain.
Okay, thank you.
Should we actually write LaTeX with Greek letters as T is tau, E is epsilon, and X is chi? I mean, yes. So, because originally back when TeX was released, font space was big, because the original TeX, I believe, was only 7 bits. So they didn't have room to duplicate the Greek capitals, which conveniently look identical to the standard Roman capitals. But in modern Unicode, the Greek capitals are actually encoded separately. So you actually probably could write it the proper way. The problem then is that it would, of course, look identical, and it would probably confuse some search engines. But yeah, actually to change the TeX macro in like some format to produce the proper uppercase Greek letters, it's kind of an interesting idea.